Good afternoon, everyone here in Oxford, and good morning, good afternoon, good evening to everyone joining us remotely from wherever you are. Thank you all for taking the time to come to our seminar in this seminar series that we at the Oxford Poverty and Human Development Initiative jointly host with the IAP at George Washington University and the Human Development Report Office at the United Nations Development Programme. Today is the fourth session in our series this term, and for our special spooky Halloween, we have our spooky co-host, Professor James Foster, with us, who is going to deliver a paper co-authored with OPHI Director Sabina Alkaya, entitled Unidimensional Underpinnings of Multidimensional Counting Measures. What we try to do in this series is to invite discussion on innovations and applications of multidimensional poverty measurement in academic circles, as well as with policy folks. And to that end, have discussants and speakers who are at the frontier of using these poverty measures for academic analysis as well as policy applications. A bit of housekeeping before we get started and before I hand the screen and the mic over to James. We're recording this, so anything that any of you here in the room are saying, or also folks online, if you're going to participate in the Q&A later on, just be aware that this will all be on the recording. We have about 30 to 40 minutes presentation by James and I believe also by Sabina, and then have time to discuss with all of you. If you're online, please use the raise your hand function and the Q&A in the chat box. And if you're here in the room in Oxford, just make yourself noticed so that we can also bring your questions into this. So without any further ado, James, over to you.
Thank you so much, Jacob. That's quite interesting to hear the spooky sound of a voice coming from nowhere. That was just perfect for today, I'm afraid. All right, so let me start sharing my screen. Everything okay? Okay, fantastic. Well, great. Well, here we are, and I'm James Foster, and Sabina's in the place over there, as you can tell. She's around, and I wanted to make sure yeah, it's working great. So it's wonderful to be here to talk about this paper. It's hot off the press. In fact, it's not off the press. We're still working on it, which means that you are both beneficiaries and have cost of being in today's presentation, because it is not as refined as many of the ones that I try to do. It's the first time I'm presenting it. So let's start off. There's a really extensive literature on unidimensional poverty measurement. It all began with identification in the old days, with a couple of the really important papers that innovated in London and in New York. And then, of course, in the US, we had over the years, many discussions of how to set a poverty line to identify who is poor. And then sometime around the 1960s and then into the 70s, Watts, Sten raised this issue of, well, there's also something you do after you identify who's poor. You have to aggregate to get an overall measure of poverty, and who's to say that head count is the right way of proceeding? This led to an onslaught of papers, including one by myself, FGT paper in 1984. And much of this stuff was implemented with the help of the World Bank's POV-CalNet. So in fact, things went from theory to practice pretty quickly in terms of the measurement discussion, and also discerning between measures through properties was rapidly enacted through a lot of surveys. I wrote one in '84, Donaldson and Waymark in '86. There's Zhang wrote one more recently, Chakravarti. Many people have written surveys on these properties, and I include one here from our book, going through the various properties of poverty measures. And then finally, there's a large literature that came up afterwards that said, well, look, if you can't really pick the right cutoff or the right measure, perhaps you can still make some kind of comparison using poverty. And Tony Shorrocks and I wrote a paper back in the early 80s, which then was published in 88. Atkinson wrote a wonderful paper based on some of those results and then extended it to including measures, and Ravalian popularized it again for the kind of popular users at the World Bank and other places. So there's this huge literature on unidimensional poverty measurement. In the 90s and say 2000s, there was a effort to extend to multidimensional measurement, to include more dimensions than just monetary dimensions, or as I called it, economic dimensions. And this was prompted by a lot of stuff happening at once, the WDRs, the capability approach. There were two WDR World Development Reports in the 1990s and the 2000s, which just came down wholeheartedly on the notion of we need to do something to evaluate multidimensional poverty. But of course, it turned out that there wasn't many measures at that point. So a lot of papers came up, and there developed two main approaches to incorporating many dimensions into a single measure. First, some papers combined variables together before applying the various cutoffs. Usually a cutoff was given in each, but in this particular exercise, the specific cutoffs in each really didn't matter. It was the aggregate of the cutoff that wound up setting a cutoff in a kind of unidimensional approach in the unidimensional variable that was created by throwing together these different variables. So it was kind of an extension of the unidimensional approach to multidimensional. And in that sense, it was in terms of measurement stuff, it was basically still back over here in unidimensional. The second approach was more, made use of the individual deprivation cutoffs in a more coherent and important way. It applied cutoffs and then obtained typically measures in each dimension and then combined them overall into an overall number based on the component unidimensional measures from each dimension. So the second approach was the new stuff here. Both of them relied heavily on unidimensional underpinnings. The measures that went into both of these sorts of multidimensional measures were typically the FGT or a Watts or some other measure. The properties were quite analogous and so forth. Now, in 2011, Sabina and I observed that this previous literature, the earlier literature, had emphasized aggregation and described the properties of measures, but effectively paid no attention to identification. And hence, they seem to be not caring about the important role of targeting in poverty measurement. So if you look back at the previous two approaches on the previous slide, combining the variables before cutoffs, man, that required being able to aggregate all these things together. So that's a lot of assumptions there. It required, commensurate variables. So the previous discussion had basically said, look, we're not paying attention to identification. We're going to use whatever we used with unidimensional. We're going to use whatever we used over here, which said, hey, if we're going to look at in number two here, sorry, I apologize. In the second approach right here, what we do here is just use individual unidimensional poverty measures and aggregate them up. So the only way that you're counted is if you happen to be someone who is deprived in one thing or more. Oh, that's it. So anyone who's deprived in anything is considered to be poor for the purposes of our measurement. And that is a union approach. So essentially, they were implicitly ignoring, what's going on with identification by using what was done previously in multidimensional, or by basically assuming implicitly that you were using union. And then they delivered measures that were non-robust to ordinality, or incommensurate variables. What I mean by that is that if you used an ordinal variable that had categories that were from high to low, and you assigned a number to that, a scale to it, and then you said, no, I'm going to use a different scale, you'd get different measures of poverty. Likewise, if the variables, don't come in units that are comparable, mashing them together for the first approach, it really seems to be quite questionable. And for the second approach, most of those measures that were part of the components use gaps, and therefore you had to be able to put the gaps together and make sense about the variables. So both of these seem to be missing from the literature, so we address them. We address both the question of identification and of the measurement issues. And we did so using so-called counting identification literature. We went back in that literature, which says that basically a person is poor if you're deprived enough, according to a weighted count of deprivations. Mostly it's unweighted, but we allowed for the generalization to weighted count deprivations. And the key figures there included Mack and Lansley. Tony Atkinson coined the term counting, and so forth. By the way, this literature, while it focused heavily on identification, it pretty well ignored aggregation. So they were back in the world where you use only the head count ratio. So what we did in our paper was to bring counting to the aggregation step. We adapted the counting identification into a measure and also used kind of counting or the score of an individual in terms of the breadth of deprivation as part of an averaging up to get the overall measure M0, the adjusted head count ratio, or the MPI. So these are counting measures. Notice that M1 and M2 from that same paper required cardinal measurement because it was an adjusted poverty gap, therefore requiring measuring of depth. So we won't consider them in this particular paper as counting measures. So the second part of that paper was to adapt the properties that had been used in unidimensional or multidimensional to the context where they would make sense in counting measurement. And that includes dimensional monotonicity, which keys off of the fact that people are becoming deprived in an additional or less deprived in one or more dimensions. That way of thinking is not something that is as natural to people focusing on just general aggregation. So we brought that into the picture in our paper. So there are now several counting measures, including multidimensional head counts, the usual head count in many dimensions, Mexico's MPI, which is based on a kind of a different way of establishing who is poor, in that, I mean, it still uses the similar kind of counting approach, but then when you translate that to the measurement question, you knock out part of what is going on in terms of the dimensions that weights and dimensions of deprivation, and include only the kind of marginal situation, which is the types of deprivations that come from the social side of things in the Mexican MPI. In any case, it is a different structure, but it's a counting measure nonetheless. There's an M gamma measure that we've introduced that relies on squaring gaps and thinking about generalizing so as to obtain a kind of analog which would have more sensitivity to inequality. These measures are out there. It seems that this is the appropriate time to consolidate the theory and to clarify the links to underlying unidimensional measures from these multidimensional measures. So the motivating question that I'll be using today or talking about today, can counting measures be usefully recast as unidimensional measures? If so, what then is the underlying attainment variable that's going to be the object for that measure to measure? Okay, such as income in the case of unidimensional typical measures. What is the analogous attainment variable which we're going to be using here? How might the properties of the counting measures trace back to the unidimensional properties that we just briefly discussed? Can the resulting insights help in interpreting and evaluating multidimensional results? So that is a question that you'll have to conclude on. I'm going to try to do my best to think that to convince you that the answer is yeah. So the goal of the paper is to reveal the unidimensional underpinnings of counting measures. So we'll do a review of unidimensional and counting measures and their properties with perhaps some new insights on identification. And then we'll define the attainment count distribution, the transformation, and the measure, reinterpret all the counting measures or the ones that are out there via unidimensional measures, and then link unidimensional and multidimensional properties. There is no empirical example as of yet, but that's on the drawing board. So now let's briefly go through unidimensional measures in a way that I wanted to lead you to, the attainment count approach. So here's some definitions. Distributions are represented by vectors, I'll call it U or V of incomes, where a population size N can be any natural number. Identification function, in this case, phi of U is an N vector where phi I of UI, the ith coordinate, is 1 if person I is poor and 0 if not. So phi of U gives a vector, really the poverty profile for the entire economy. Now we assume uniform individualistic identification, by which I mean here, since phi can be defined on vectors of any size, including a single person, that phi of U1 through UN of the whole society here, let me put a comma in there, is equal to the vector obtained when you apply phi to just U1, the first person's income, comma, U phi of UN, the nth person's income. So what it says is that it's individualistic. It depends only on an individual's own income. And secondly, it's uniform in that it's the same function, if you will, for every person. Then I assume that it's not increasing in you, by which I mean poverty status should not go up. You should not become poor as a result of an increase in income. And then non-triviality means it takes values both 0, that a person is not poor, and 1, that a person is poor. So in other words, at some incomes, it could be the person could be poor or not. Well, what's interesting is that with these assumptions, essentially, you get poverty line cutoff identification, which means that there exists some cutoff Z. That should actually be pi, so I'm going to change it right now, such that each person's individualistic identification function is either of the form phi Z interior, if you will, or 0 pi, okay, where this function says a person is poor if the person has less income than the poverty line pi, and the person is not poor, i.e. it's 0, exactly when income is equal to or greater than pi. Okay, does this make sense? This is the sort of standard form of identification. You're poor if you have less income than the poverty line. Zhang in his survey points out this is really the standard form that everyone is using or should use. Otherwise, the cutoff doesn't really qualify as a minimum acceptable. On the other hand, back in '76, Amartya Sen used a different definition which had weak inequality. And so I denote that with the same phi pi, but without a circle. So it allows the equality, and it says a person can be poor if your income is at or below the poverty line pi. So there's just a minor difference whether you're at that line, whether you're poor or not. Okay, that distinguishes between these two. Now, there was a lot of discussion about this in the old days. I'll mention one of the reasons why you might not want to use this one in general. Option 2 does not work well with certain measures. You know, this can be seen by looking at, actually, this was mentioned by Donaldson and Waymark, but they didn't quite do it this way. Consider the following axiom: poverty monotonicity. If X, and this should be actually U, V, my apologies, I'm showing that I haven't gone through this and clarified everything. If U is obtained from V by a poverty status altering increment, that means it alters poverty through an increment, means someone got out of poverty. Then poverty should fall. U's poverty should be less than V. That seems very natural. But this will not be satisfied if you use a continuous measure, because the person right at the poverty line increased by even a small amount out of poverty. That person's being out of poverty made no difference whatsoever. So therefore, poverty monotonicity is not satisfied by these continuous measures. However, it's perfectly fine to use discontinuous measures like the head count ratio, or say the convex combination of the head count ratio and the poverty gap, which I'll talk about in a little bit. Does this all make sense, or should I stop for a second and make sure that everyone is following? Jacob?
I think you can go.
Excellent. So, definition: the aggregation step takes the identification function as given. Poverty measure P gives the poverty level P of U associated with distribution U. That's how aggregation is going to take place. Axioms are little nuggets of policy indicating what is to be ignored, what matters, and gives you tools for doing policy analysis. There are restrictions on P given phi, or as we oftentimes use in the discussion, the methodology combining those two.
James,
Invariance axiom.
Take a clarification question.
Yes, please.
Sorry, we're a bit late, but there's one clarification question, please.
Thank you. I am a visitor from California, and I'm really pleased to be here. And I'm wondering, I may have missed this at the very beginning, but I'm wondering if you would be willing to say your overall hope or intention in what you would like us to gain from the lecture, so we know what to pay attention to.
I hope that you can, thank you. I hope that you will be able to see how the new forms of measures that have taken over the accounting measures have really gone into the world and have been used again and again by countries, by the UN, these new counting measures, in particular in the form of this adjusted headcount ratio that I'll define in just a second. How that structure, which can seem to be rather complicated, actually is related to basic measures that have been used a long time in Unidimension for measuring monetary poverty, and how the properties are analogous in really quite useful ways, and how the insight from that we've gained all these years from unidimensional poverty can actually be exploited when we're looking at multidimensional poverty. That's basically what I'm trying to get at. I'm also, there's one other thing I wanted to make clear, that there are certain ways that the existing mode of poverty, the unidimensional poverty measures that's been there for a long time, does not explain the parts of multidimensional poverty that it doesn't explain relate to an axiom called dimensional breakdown, whereby the overall measure is separated into its constituent dimensional parts. So poverty that is due to deprivations in health or deprivations in an education variable and so forth, how that is built back up to the overall measure and torn back down into these individual, what we call censored headcount ratios for our multidimensional, the adjusted headcount ratio. So how that can be so useful in analyzing poverty, and yet there's nothing quite like it in the unidimensional approach, so that when we take and construct new measures from unidimensional approach to these multidimensional approaches, I'll show how to do in a second, you're still not going to be sure that you're satisfying that extra very important property. And you'll have to look carefully to see whether the measures that you construct do indeed have this convenient and policy relevant attribute. I hope that that isn't too crazy. So follow-up question?
No, that's helpful. Thank you.
My pleasure.
And where are you addressing us from? Where are you physically located?
Oh, my apologies. I'm here right in the downtown. In your mind, I'm in downtown Washington, D.C. The George Washington University in the Elliott School of International Affairs.
Thank you.
Okay, James, can we have one last clarification question? Then we'll
Absolutely.
Presentation. Thank you.
If it's okay, could you briefly clarify what the variables in the equation mean again?
The variables here, the ones that are the U's, you're talking about the variables of, you're talking about these U's here. Is that right?
Yes, that's right.
Okay, they're in the unidimensional approach, they typically are income or consumption of an individual I. So UI is person I's consumption level that has been processed and figured through to take into account all the different aspects that a person is, the value of different things, all combined to a consumption level or an income level by which poverty is typically measured. So in the US, there's one approach to doing it. In other countries, there's other approaches to doing it. And by the way, it isn't just a monetary approach. It could be something like calories if you're just measuring poverty in the consumption of food. So this is in fact what we did in our paper back in '84. But the entire reason for doing this is to take the structure that's been established in the unidimensional, primarily in the monetary world, and consider what that does for the multidimensional world. Does that make sense?
That makes sense. So it can be a variable like both monetary or even related to like food, like calories. It can be.
In fact, the measures that I'll talk about later, the FGT measures, have been used to measure probably 300 or 400 types of deprivation or poverty, including aspects of the environment, including space in a house, including how old an economy is in terms of age. It can be used for anything as long as you have a single variable.
Right. Thanks, James. Okay. Stefan, we'll let you continue. We have about 20 minutes.
Thank you so much. So the aggregation step I've talked about, and I mentioned what axioms are. They're ways of incorporating the directions where poverty is going to go down or go up will happen. We want that to be the way that things will happen. That's what the axiom says, that poverty should fall if people's income goes up enough and stuff like that. So let's talk about these three different types of axioms. The first is invariance axioms. which are basically symmetry. Everyone should have an idea. Symmetry says it doesn't matter if you measure person 1 first or person 2 second, or switch them around. The measure itself should indicate that the level of poverty is the same no matter what number the person happens to be. Likewise, if you create a clone of each person, as we've done here, then poverty should be unchanged. This is so-called replication invariance. Third, the focus axiom says that if you have a non-poor person, which given that the poverty line is 4, a person with 7 certainly is non-poor. If you raise that income to 8, there should be no change in poverty. Focus only on the poor people. Dominance axioms, and let's suppose we have, again, poverty line equals 4 in the examples, say that poverty goes up or stays the same whenever U is obtained from V by a simple increment. So you see what I mean by a simple increment. I've increased the income of the first person by 1. Poverty should not rise. That's what it says. A progressive transfer among the poor should not increase poverty. So in this case, we have person 2 giving person 1 $1, leaving us with 2 being the distribution. This should not have the impact of increasing poverty. Now, poverty will actually fall, so there's a strict inequality here, when U is obtained from V by a simple increment among the poor. If that's the case, if we have a strict inequality when we raise the first person up by 1, and let's satisfy weak monotonicity as well, because there's some other things that entails, then we obtain monotonicity. So monotonicity says, wait a minute, things are going to strictly go up, not just weakly. If a poor person has less deprivation, or strictly go up if a poor person has more deprivation, is further away from the poverty line, or poverty will fall strictly if a poor person has an increment. A progressive transfer among the poor implies that you will have a strict, and this should actually be strict, my apologies, I don't know why that's there. What will happen then with this type of measure satisfying the property of transfer is that a progressive transfer among the poor will lead to a strict decrease in poverty. So here we've taken and transferred across 2 people, and we obtain a strict lower amount of poverty. The subgroup axioms say a weighted average of these 2 subgroups now, 2 different groups in a country. You can take the measure and decompose it by subgroup with the following way. Take the poverty level of the first subgroup, weight it by its population share, add it to the poverty level in the second subgroup, weighted by its population share, and you can obtain the overall level of poverty. This is called, as I said, subgroup decomposability. And there's a more basic property that says, well, if we raise the level of poverty in U, or maybe I should say lower to keep it simple, if U is lowered in terms of its poverty to U prime, and V prime have the same level of poverty, then overall poverty should fall, at least when you don't have any migration or the number of people doesn't change. So that's subgroup consistency, which ensures that local policy to improve poverty has the same effect overall. The kinds of measures that are out there include the head count ratio, which is basically Q over N, where Q is the sum of all the identification numbers, 1 for people who are poor, 0 for people who are not, and divided by N. So it's the percentage of the population who's poor. The poverty gap ratio looks at the gap of each person who is not poor. Notice this will be 0 for people who are not poor, ignores it, and then focuses only on people for whom this is 1. Hence, we have a gap for a poor person added to the gap of another poor person, et cetera, et cetera. And then with zeros for non-poor, add all that total normalized gap up so that you then realize, on average, what percentage are the poor people below the poverty line? And that's this measure. It's equal to the head count times an intensity measure, which just considers this over the poor, the gaps over the poor. The Watts measure has this form. Once again, kind of interesting. You're subtracting the log of the poverty line from the log of the poverty line, the actual log of the income. The intuition can be in terms of some sort of welfare function. That's what the log would be proxy for. We don't need to get into it. The FGT index can be written the same way it's the gaps, the normalized gaps to a power and averaged up. Notice G is P1, H is P0. And when this is squared, you actually have the squared gaps, which really emphasize the poorest of the poor. Now, I mentioned the augmented gap function here. It has the same form as the usual gap, except there's a different standard being used when comparing a poor person's income to a standard. So this standard gamma, delta, could be a regular old poverty line, and you're using to identify people an ultra poor poverty line. And so you're measuring from the regular poverty line, but only for the people who are ultra poor. That would be a way that an augmented gap measure might be useful. It also can be seen as an average between the head count ratio and a gap with a particular averaging form. So it's kind of like throwing together the first 2 measures of the FGT indices in convex combination to one another. By the way, this last measure and the head count don't have that problem in using the weak inequality identification, because actually the poor person who's there on the edge counts. It counts in the head count, and it counts because we have a head count as part of the gap. So if that person actually becomes non-poor, you see it register in these 2 indices. So multidimensional poverty measures build up from their forms of distributions, which are now matrices. So matrix X or Y, they have a fixed number of columns. So over here are the columns. There's D of them. And then a fixed number of rows. No, it can be any number of rows. N equals N of X. So each X has its own N. And that is the matrix X in there, which has, an entry for every I and J, I being a person, J being a dimension or a column. A deprivation function, gamma of X, yields an N by N matrix, which basically says gamma ij equals 1 if person I is deprived in variable J, and gamma ij is 0 if not. And the point with this is, by the way, the same as the old-fashioned identification matrix. It's viewing it as a function of X. And that identification matrix had 0s and 1s, not weighted in this case. So I'm keeping that separate here. So the deprivation function tells you if a person is deprived in a particular dimension. So the dimension could be health, it could be a dimension from education, it could be one of the MPI dimensions. We assume uniform individualistic functions. This gamma is uniform individualist. So it means that gamma ij basically depends only on xij. In other words, the jth amount that person I has. And so gamma j, this special function which tells you whether you're deprived in the jth dimension, depends exactly on person i's entry in that dimension. And it's the identical function across all people. So every person is gauged using precisely the same rule. We assume that this function is non-increasing and it's non-trivial, and therefore you know from our previous discussion that we're going to get deprivation cutoff identification. That means that there's some cutoff, say zj, so that this identification function drops in value from 1 to 0 or 0 to 1, going backwards at that cutoff. Now, we don't know what it's going to be at the cutoff. Let's assume that we know that it's going to be non-poor at the cutoff. So it takes the structure of the standard type of cutoff function with a strict inequality. That's in fact what we adopted in our work. So next, poverty identification. Let's let Z be the vector of all those cutoffs that were just shown to, they must exist, given the assumptions we just satisfied. So these are the dimensional cutoffs. This tells you how much, if you have income in there, how much income would constitute being deprived in income, what your cutoff level in self-reported health would be, and so on. Poverty identification function, rho, is an n vector with rho equals 1 for person I, the ith coordinate, right? If person I is poor, and rho I, the ith coordinate, is 0 if it isn't. So if you see a vector that goes like 1, 0, it means the first person is poor and the second person is not. Okay, we assume uniform individualistic identification. Again, I'm saying it for the third time, which means that everyone's poor depending on their own vector of the different dimensions. Okay, so this is I's row of data. And so my status depends only on my row of data. Let's assume it's not increasing in each entry and takes values that allow people to be poor and non-poor. Now, there are many consistent identification functions satisfying these assumptions. Since xi is a vector, it isn't scalar, as was done in the previous two cases. Our approach is to use a counting identification based on dual cutoffs. I'll explain that in just a second. So, definition. The aggregation step takes rho as given, and then the measure gives a poverty level associated with a distribution X. Now, what properties should a poverty measure satisfy in this multidimensional domain? I'm going to drop the Z from the statement, so it's just M of Y and M of X. The restrictions on all of these are joint. So we get, once again, symmetry based on permutations. Instead of person 1 having 1, 3 and person 2 having 2, 5, it's the other way around. They should have the same level of poverty. Likewise, replication, same level of poverty. Deprivation focus says that if you increase the achievement among someone who's non-deprived in that dimension, then there should be no impact. So if Z2 is 4, so here's the second coordinate, right? We've increased this person who's not deprived over the cutoff to 7, and it should have no impact. That's deprivation focus. Poverty focus, and this is a new property that is not really analogous to anything in the this is quite a different type of property. Going back to poverty focus, the increment among the non-poor, if you increase and if you have someone who's not poor and you increase anything for that person, it should have no impact on poverty. So if row of 2.5 was 0, that means that person here would be non-poor. Then increasing those 2 entries outlandishly shouldn't impact a thing. There are dominance axioms that say if you increase just 1 entry, then you should have poverty not rising. There's another dominance axiom that says if you switch 2 persons, so let's see a switching that takes place here. So person 1, okay, person 1, and actually this is kind of interesting. Person 1 switched sorry, I'm a little bit flaky here. Let me pull myself back from this. We have person 1, 1.3, person 2, 2.5, and now what happens is that person 1 and 2 switch their first entry. So person 1 gives person 2 their first entry and so forth. Then you wind up with 2.1. Now notice in the first case that back over here we had back over here, I apologize. So back over here we had person 2 was unambiguously, I mean, had more than person 1 for sure, even though both are poor. But this switching around deadens the kind of strong inequality that occurred because this person is really dominating this person a lot. So this breaks it up and makes it so that person 1 has a dimension in which they're dominating. Atkinson and Bourguignon called this, well, other people called it a switch. Atkinson and Bourguignon said this should deflect the correlation across dimensions and therefore lessen the inequality. Given that it lessens the inequality, and we want the measure to be inequality sensitive, more or less, we then require this to have the new, more equalized distribution to have lower poverty, or at least the same amount. So weak transfer. Dimensional monotonicity is something different altogether. We start out in this example with person 1 is going to stay poor, but will have 1 less deprivation. So we have 2 people who are poor, but then person 1 is going to stay poor, but they get something that puts them over the poverty line, over the cutoff, I mean. And it means that that person is still poor, but actually they have 1 less deprivation. Going in the other direction, they have 1 more deprivation this way. And the strict inequality should apply in this case when a poor person is relieved of a deprivation and stays poor, or it should poverty should rise if a poor person it has an additional deprivation added on to them. That's dimensional monotonicity, and dimensional transfer performs the same switch, but then it has to be in terms of a situation where one of the persons is not deprived, so that the switch actually changes the deprivation of person 1 as a result of the switch. If it changes the deprivation profile of person 1, then we require, this should be strict by the way, then we require strictly poverty has fallen. That's dimensional transfer. Subgroup axioms are identical as before. The different,
James.
got it. The different measures that are out there include the head count ratio, which is, you can use either form of identification, whether it's strict or weak, it wouldn't matter. This just violates dimensional monotonicity, and dimensional transfer just means that It doesn't go badly wrong. It has equality, but it still goes against those two axioms because of their strictness. The adjusted head count ratio for X given the identification gamma and weights summing to D can be defined quickly as follows. You take the dimensions in which people are deprived, and there's a 1 attached to them, therefore you'll count the weight for those dimensions. And for a person I who's not deprived in, let's say, D, this will be 0. So therefore the weight will not count. Add up all of those weights weighted by whether or not people are deprived of them, and you get a count, the deprivation count. So it's adding up all the weights for each dimension in which a person is deprived. You can obtain the deprivation score by divided by the total amount. If you added up all the weights, they would add up to D. So divide through by D, and you get, therefore, the deprivation score or share. Counting identification says a person is considered to be poor if their count, the CI, exceeds the cutoff K or is equal to it. A person is considered to be non-poor if their count, deprivation count, goes below the cutoff K. Okay, so this is the counting identification approach. Censored deprivation count takes the original count that we had before and multiplies it by whether a person is poor or not. So if a person isn't poor, then you don't count their deprivation count. Likewise, if a person is non-poor, you don't count their deprivation count. If a person is poor, you count it. Likewise for the deprivation score. The adjusted head count ratio can be defined as the average across all people of their scores, the censored scores. So what you're doing is you're taking deprivation score for person 1. You're saying, okay, we can see that that's a percent, right? And then we take a look over here at person N, their percent. Now for the person who's non-poor, it's going to be 0. Average all of those up, and you obtain the adjusted head count ratio. This measure just violates dimensional transfer. The rest of the axioms are satisfied with it. Now, from unidimensional to multidimensional, the idea is to use the elements of the counting approach, namely deprivation on identification and weights, to derive a multidimensional methodology from a unidimensional. So we restrict consideration to unidimensional with a cutoff between 0 and D. The attainment count vector associated with X is defined as, well, each person subtracts their count from the total. So it's the weights of all those dimensions in which you are not deprived, added up. That's for person I, and then you configure the vector, and that is the attainment count vector. Another way of viewing it is, as I said, it's just basically adding up all the weights for which a person, here a person is not deprived in it. So this becomes 1, this is 0. So therefore the weight counts. You add up across all people, across all dimensions, in the case where you're deprived, it counts. Where if you're not, you're deprived, it doesn't count. If you're not deprived, it does count, and you get the attainment count vector. The attainment count methodology associated with an underlying single dimension or unidimension methodology. So a methodology is an identification approach and a measure. It's defined as the identification is basically found by applying the single dimension identification to I's entry in the attainment vector. And the multidimensional measure is found by just applying the poverty measure, single dimensional poverty measure, essentially to the attainment vector, again, taking into account the identification here. So this is the transformation from single dimension measures to the attainment count measures. The attainment count transformation is the mapping from this script P to the script MP. Note that MP actually employs a dual cutoff identification with cutoff K, so that either you're doing the usual stuff, which has a weak inequality, or does a right, which has the identification in multidimension is rho K, which is our usual counting approach that says you're poor if you have the number of your, your score, your count is greater than or equal to K, and you're not if you're less. There's an alternative approach that's obtained over here, where you use, this is interesting, I think I switched these two in the terminology here, my apologies, ignore this. It should be absolutely clear what I'm defining here, because rho K here means strict below the, strict above the cutoff means that you are not deprived, and if you're below or equal, then you are, sorry, not poor, below or equal, then you're poor. So it turns out that you get a dual cutoff identification, but where you're at that cutoff can be one way or the other. The idea of the proof is you just transform the variables and you find out that's exactly what you've got here. You're back in the world of Alkire and Foster. So it turns out also that we obtain ordinality, by which I mean is if you rescale all variables and the poverty lines, the poverty cutoffs here, the deprivation cutoffs, that poverty is unchanged and who is poor is unchanged. And I give an idea of the proof, but don't have a whole lot of time. Okay, it also satisfies deprivation focus, because obviously you're using the attainment vector, and that doesn't register anything when someone who is not deprived has a change in their status in that dimension. The first example, just throw this out, you find that no matter what identification you have for the standard head count ratio, you get a multi-dimensional head count ratio. It could be either the usual one in the Alkire-Foster, where you have the weak inequality going so that you could have CI equals to K and be considered to be deprived, or you could have the strict version. Both are counted as the sorts of attainment count measures. Our measure, the adjusted head count ratio, is obtained by using the unidimensional augmented gap and by using the standard type of identification at a cutoff. So with the weak inequality, the resulting attainment count methodology has the usual dual cutoff identification and has the M0 MPI, just the standard adjusted head count ratio. By definition, you can go through this proof and you just see that the definitions cascade down to get us exactly the definition M0. Note, this, which uses the weak inequality, presents no problem with poverty monotonicity in this context, because people right on that cusp they count in terms of M0. If that weren't the case, we would have problems, which is why the weak inequality works quite okay there. Mexico's MPI uses the standard gap and the alternative identification with strict. The M gamma class, which we introduced in a paper in 2019, uses the weak form here of identification and augmented FGT, where you measure from D, not from the cutoff of the poverty line. These measures allow us to, in fact, take into account strictly the kind of transfer axiom, the dimensional transfer axiom, when alpha or gamma in that case is equal to 2. We gain dimensional transfer, but we lose dimensional breakdown. And in fact, I'll be talking a little bit more about that, but I'll just mention here are the implications for properties, the singleton types, unidimensional properties here, multidimensional properties here. Here are the analogs. If script P, the unidimensional methodology satisfies symmetry, then the attainment count methodology satisfies symmetry. Replication invariance. Focus implies the poverty focus axiom. Weak monotonicity, weak transfer give us the analogous. Monotonicity for the single dimension gives us dimensional monotonicity for multi-dimension. Transfer for single dimension gives dimensional transfer for multi-dimensional. And we obtain the analogous, comes directly from the subgroup consistency and decomposability of unidimensional. We get the multidimensional analogous axioms. The only part of the proof that's at all relevant are these last two, and I don't have time for it, but I'll just say some really quite nice subtleties about how deprivations or switches, increases in deprivations, decreases in deprivations, or switches in deprivations are implying the dimensional monotonicity, dimensional transfer in those cases. I should mention there's no unidimensional analog to dimensional breakdown, quite naturally. This requires that after identification, a multidimensional measure can be broken down by dimension. For M0, it means you have overall M0 can be obtained as a weighted average of the censored head count ratios, one for each dimension, where those refer to the percentage of the population that are both poor and deprived in the particular dimension. So this turns out to be quite a useful tool for policy analysis. But unfortunately, if we create measures the way that I've done through the transformation, it turns out that we don't have anything to ensure that we get this type of a property from our measures. Sabina, I'm so sorry to leave you nothing, but please chime in now with your discussion of breakdown.
Thank you so much, James. No, I think that we'll move really to discussion and interchange, but I think just putting a point on James's final observation about dimensional breakdown, what we know is that many of the policy uses of the adjusted headcount ratio do use that adjusted, that dimensional breakdown, because you can then use it for targeting, use it for policy design, use it for budgets, etc. And so it would be possible that a paper of this sort, which basically shows how using the attainment count methodology, you can create a Watts, or you can create a, any of the different unidimensional measures, and you can understand their properties, that could lead to a flurry of new measures. But what we want to do at the end of the paper is just say, be careful, because it seems that the policy relevance requires this dimensional breakdown. And so creating a bunch of other measures might not be the most important in empirical terms. The M gamma class, of course, does, stepwise. It has the headcount ratio, it has the adjusted headcount, and then it has the M gamma measures that reflect dimensional transfer. So in that way, one could have a step through of other measures. But anything that reflects dimensional transfer will need to take the full distribution from D, not from K. So I think that's the important, tweak at the end of this paper. But thank you so much, and over to discussion.
Thank you very much, James, and also Sabina, for a very comprehensive and clear presentation, and for being so patient with us and taking our clarification questions as well. We now have time, at least a few minutes left for questions both from the online audience. So if you have any questions or comments, please just pop them into the Q&A box or raise your hand directly. And we can also take questions from folks here in the room, of course. So if there's any question here, just wave your hand at me frantically so that I see you. Maybe I have one question actually. So
Yes, Jakob.
the underpinnings, as you explained them, especially from the FGT and P0 and P1 to the multidimensional headcount ratio, and also M0 as perhaps an equivalent of P1, are very clear. I was wondering if you both could say a bit more on the additional complications that you mentioned now towards the end, of moving further in terms of looking to extend also P2 or other forms of more transfer sensitive measures to the multidimensional realm. You already mentioned some versions of these transfer axioms, James, and then with your M gamma class, of course, and you pointed out to the policy trade-offs between dimensional breakdown and respecting these things. I was just wondering if you had any additional thoughts or insights for us to understand both the trade-offs involved, or how one would go about also extending this very inequality sensitive unidimensional measure, so the squared gap to the multidimensional realm.
Right. Well, I'll just say it can be done, obviously, and has been done now. The interesting part is that you can actually understand what you're measuring in terms of now linking it back to the kinds of ways that measures have been used in the unidimensional world before. You can get a sense as to what the numbers mean and all that. That's all very helpful. The difficulty winds up being really making sense of the number that you have and relating it to policies to address poverty. Yes, if you get rid of some deprivations, you will, among poor people, you will indeed alter the level of poverty, even in those cases. I mean, you will do so. But setting up the priorities as to which you should go after, what regions have this, a profile that now we need to focus on one dimension versus another disproportionately. All of that isn't allowed by using measures that don't have as clear a breakdown as the MPI. In particular, if you look at the Mexican measure, it does have a kind of an additive thing, but the breakdown goes away because it doesn't make up for the entire extent of poverty. So it's really quite interesting. Sometimes the ways that breakdown is violated are quite subtle, and they're quite harmful for trying to do the analysis. Of course, the M gamma class, if you look at the M gamma 2, you can kind of get a formula that relates things by breakdown to overall. But again, it isn't as straightforward. It's quite interesting. It's subtle. And it does have some, I think, new insights in it that we should utilize. But the tried and true M0, it's going to be difficult to improve on as far as I can see. Sabina, could you please comment?
Yeah. So, I mean, you put the point on it, Jacob. There are two different reasons that dimensional breakdown has problems. In this paper, if you have an attainment matrix and you set a poverty line, let's say D minus K, and then you use that number as the shortfall, and you make any, P1, P2 watts, whatever, from that, you don't have the full matrix and you don't know what you're getting in terms of the deprivation. So you've lost the link to the matrix. So that's what this paper is observing, that as James was saying, in order to get dimensional breakdown, you identify people using a poverty cutoff, let's say 33%. But then their deprivation score goes up to 100%, right? It goes from 33 to 100. So any deprivation of any poor person is included. And that's not the case if you go from K. So actually the D many deprivations is what gets us dimensional breakdown. If you turn to the other working paper 126 or 7 on the role of inequality in poverty measure, we also see an impossibility in that dimensional breakdown requires a linear structure and dimensional transfer requires some power, right? Raising it to some power so that you have an ability to emphasize the poorest of the poor. And so that is incompatible. You cannot have any single measure, a class of measures, yes, but any single measure that both satisfies dimensional breakdown and satisfies dimensional transfer. So that's what the second paper did. So in both papers, we're looking at different extensions, but then we keep coming back to the fact that dimensional breakdown is really important for policy, and you really can't get at it in these other measures that we're exploring. Over.
Fantastic. Thank you both. Do we have any other questions here in the room at the moment? Don't think that's the case. We have 3. Let me just check. There's something in the Q&A. Bali says he's on a train, but says thank you to both of you. Then we have one question. If the material is going to be made available, I'm not sure, James and Sabina, if you're happy to upload the slides.
In time, but yes, I will upload a corrected slide pack.
Okay, so basically we'll upload the recording and then Temeslev will also upload the corrected slides with the on-the-go corrections that James already made during the presentation. Okay, we now have one additional question here in the room, and then I think there's one other online, which I need a minute to understand. But yeah, please.
Thank you. Sabina and James, I just wanted to say as a visitor to the Institute, this is Dr. Paloma Pavel, and I've been writing in advance hoping to see you today, and I was very lucky to be able to join this lecture. I want to thank you all, and I'm traveling from California and the University of Oslo en route to the UN meeting in Egypt, and hope to be following up by mail. And thank you for this opportunity to be here in person with your attentive fellows and students here. Thank you.
Thank you, Paloma.
Thank you.
May it go well at COP.
Great. So I think there was one final question, which was very early on in the lecture. I assume it had to do with identification and counting human rights violations. I'm not sure if either of you would want to say anything on that.
I think he's actually departed the seminar, but it might be worth saying that the Mexico approach describes their 6 non-monetary indicators of social rights. And so that's one place that one can look into an articulation of how the concept of rights and the concept of multidimensional poverty measurement come together.
Anything to add, James?
I think she said it.
Great. Sabina said it all. In that case, I think we can wrap up here for today. Thank you so much, James and Sabina, for a fantastic presentation.
Thank you.
And thank you
And
all.
let me just thank the audience, because I'm a stickler for getting things done precisely and carefully and presenting clearly as a bell. The first time I present something, it's not the case. Thank you for being here with me and enjoying the fact that I sometimes roam all over the page. So thank you so much for experiencing that and also helping me improve for the next person that I present this to.
Fantastic. Thank you, James. So thank you all online and in person for joining this afternoon. And please do come back next week. We'll have a presentation by a new report by both Sabina Akaya and our colleague Pani Koveshti It will be same place, same time here in Oxford. And if you found us on Zoom, the link should be available from the same website as well. The corrected slides and the recording will also be online for those who want to go over the equations again and study them in their own time. So with this, thank you all for joining today and see you all next time.